welcome back. Welcome back to yet another video on design pattern. This is the first video under the design pattern series. The very first design pattern what we are going to discuss is about Singleton Design Pattern. This Singleton Design Pattern basically falls under the Creational Design Pattern. Uh, one more thing I wanted to tell you all is that whenever you go for an Java interview or any other design related interviews, right? So interview will definitely ask you about what kind of design patterns have you worked on, whether you are here for just learning what is the design pattern, or you are attending any interviews and you're preparing yourself for an interview. So this video will be definitely be helpful. I'll try to share some light on like what is singleton design pattern, how to write it, what are the step by steps, when to use it. Okay, so those are all things will be discussed in this video. Stay with us. So the very first design pattern, what normally any person or any would say is that they have worked on singleton design pattern. Now things goes little bit different when like the interviewers get into the details of like what is singleton design pattern. They normally people are able to answer it, but when it comes to the pitfalls or the disadvantages or when how it can be breaked up, right? So those are the tricky questions which are just lies behind the next set of questions once you give the first initial answer to what is singleton, right? So there it gets tricky and like some many of them will fail to answer those. Okay, so let's look at it. Uh, so what exactly is singleton design pattern? Okay, so first of all, this is the creational design pattern. So there are three categories like behavioral, creational, structural. So this is the one where initialization, where you're creating an instance of an object. So this falls under the creational design pattern. Okay, and this is only required, let's say you want an instance, okay, and it should not be created multiple times throughout the system. There should be only one instance of that. Okay, so JVM ensures that when you're trying to create a singleton, when you're creating a singleton class, it will create only one instance of that and it will provide a global access point to that point. Okay, so scenario when do we use a singleton is that when you need to across the system you need a single instance. Okay, and you don't want to be load the memory with unnecessary instances, and a single instance will make your work done, right? So in that case will you make use of that. Okay, so let's look at the important points. So if you see, list down the important points. One of them is that it has to be a very single instance. Okay, it has to be created once and it has to be serve the lifetime of that particular application, right? So whenever the application is up, it will create that instance, and throughout the application is up, that only one instance will serve your request. Okay, global access. So once you're creating that particular instance, okay, so that instance at the start when it is created, you doesn't need to, when you're trying to get that instance of that particular from in any of the classes, right? You will be getting that same instance no matter how many times you get call that particular instance, right? So it will not create a new instance every time. Okay, so it will ensure that there's a consistency and single and across the uh, application there is only one global access to it. Okay, there are initialization. There are two kinds of initialization. One is easy and the eager. So it depends on how heavy object you are creating and what kind of scenario you are using it. You can use it, but the lazy and eager are the initialization when you're trying to create your instance. It's a lazy, right? So when you're trying to create an instance which is little bit not at the startup, when you're trying to get the instance, when you call that particular method. So we'll look into it. Uh, so let's check out like what are the steps required to create a singleton. Now, whether you are as I mentioned, if you're going on an interview, right? The very first question he asks is that what design pattern. Now, secondly, when you say singleton, now the next question, what exactly is that? What is singleton? Why do you use it? Okay, and post that, definitely there will be a question to understand whether you are theoretically answering this or you have just marked up. Okay, so or you have a practical knowledge. So in order to understand that, he'll try to ask you, can you implement a singleton design pattern? Okay, a custom singleton class. Okay, so the way to create a singleton class is that, first of all, you should not create a public constructor. So you should create only private constructor, so that when you're trying to create an instance of that, no matter like I mean, if you're creating a new instance, then it will be definitely creating a new instance of that particular object, right? So you should avoid that. You should not uh, allow it. Second, you should create a private instance, static instance variable, which will create that instance of that particular class. Okay, and there should be a public method, which is a static method, which will provide a global access. When you try to call that particular method, you will get that instance from that particular, that the one which is the second point, we have created an instance variable, right? That will instantiate it, initialize it, and then it will give it to that particular method in this particular method. Okay, so this is the normal way of creating a singleton instance. So now if you look at this particular code, right, there is a simple code written over here. So singleton class is written here. You have created a singleton variable over here, static. There is a private constructor over here. You have written a static method over here. Okay, the benefit of this is that the one which is you are seeing over here is that it is one of the kind of different ways of creating an instance of, and so it is lazy initialize, so that let's say this isn't just instance, but there might be a possibility that it's quite heavy, and then a lot of things, a lot of attributes, lot of work is going to happen in that. So that in that case, you doesn't load your memory, or doesn't at the start of your application, you doesn't load it. The later when it is required only, then only you create it. Okay, now disadvantages with this particular approach, whatever the instance we have written over here, is that in some cases it's not thread safe. Whatever you are writing, not all singleton implementation are thread safe. Okay, so there might be a possibility. So if you see here in this particular single static method, right? So if you see, there is an only an instance, null is checked up, and then it is created an instance. But there might be a possibility that when the if loop is being checked up, there might be another thread which has been doing the same thing and trying to access that, right? It might create a duplicate instance of that part. So this is not thread safe implementation. Now we'll look into the different ways of creating the singleton design pattern and different ways. So now we spoke about thread safe, right? So the way to create a thread safe is that we normally use the synchronize keyword. Okay, so we all know that synchronize is used to make the multiple threads to stop from accessing certain resource. So it has to first acquire that particular lock, and then perform their activity, and then do their stuff. Okay, so here you see the very first is the synchronize block method, right? So under that, if you see, the class is written, the private instance variable is created, the private constructor is created, then you have a static method. Earlier, if you see, we had seen the static method. Now we have added a synchronize keyword over here. Okay, along with that get instance method. So now if you see, it will log that. So uh, this particular method has got a little bit disadvantages, as in, like, when you're trying, multiple threads are trying to access that particular result, it has to wait for that particular thread to unlock it, right? It is acquiring the lock, right? It has to unlock it, then only it will be able to enter that particular section of the code. So it's little bit slower than compared to because its synchronization is involved. Okay, now let's look at double checked locking. Now previously what we have created with the thread safe, right, that there was a disadvantage where multiple threads which are trying to create over there, it might be a possibility that it might create two instances of that. So in order to avoid that, there was another way to create a singleton design class. So that is totally thread safe. Okay, that the previous one was non thread safe, now it is a thread safe. Okay, so double check locking, okay, it's called is one of the multi threaded sorry single threaded thread safe way to create a singleton thread safe way to create a singleton class. So the approach is same almost for like create an instance variable for it static. You add a volatile over here. If you see here, along with static there is a volatile singleton instance created over here. Okay. Now volatile is basically it's used that when you're dealing with multiple threads. Okay, you want your initialization and whatever operation you're performing, it should be visible to the other threads at the very moment, right? So it is globally accessible to the threads and not on their own local cache. Okay, so immediately it will reflect the main memory of the threads where they are trying to access, so it is globally visible. So we have a private singleton class constructor over here. Now here, if you see the public static class gets instance method. Now if you see previously there was only one null check provided. So here if you see the first line, if you see that it checks for null. So this in this case, what will happen now? I will go line by line. If you see at the very first instance, there are multiple threads also. uh, they will first check like there is a possibility that they will pass on this. Now synchronized block is added over here. Now we are trying to we have taken the lock on that particular class. Okay, and then here only single thread can enter this, right? So here it will acquire the lock, and then here if it again it will check if there is an instance is already created now, because in this first if there might be a possibility that the instance is already created. Okay, so here it will avoid the instance and then it will create. So what will happen if let's say the first if itself is get satisfied, right? If it is null, then what happens? It enters. But if it is failing, right? So it will definitely return if the instance is already created, it will return that. So so this is the purpose of having this double checking lock scenario. Okay, so this will as I mentioned, the volatility will prevent reordering, and then there will be visibility to all threads, and it will minimize the synchronization. So what happens is the synchronization is good, but it makes your processes slow. Okay, so this is one of the efficient way to write a singleton design class. Now, as I mentioned, there are different ways. So earlier, we at the very first we saw an lazy initialization. Now we are going to look at the eager one. So eager, as in like when you the moment your application is up, you will get your instance created. So whether it is required or not, this instance will be created and it will be available for you, and it will be globally available to you. So no matter they are calling this particular get instance method or not, this particular instance will be by default created at the start of the applications, right? So the benefit of this is that it's quite simple, and this instance will always be available. Now, the disadvantage of this particular approach is that, as I mentioned, it will automatically create whether you require it or not. But this is potentially like a wastage of the resources if it is not required. Let's say throughout this life cycle, the instantiation or the user has not never called that particular thing, so it's wastage of the resources, memory, etc., all of them, right? So that's the disadvantages. Now we have looked about eager I mean non-thread safe, thread safe, and double check lock. Now this is another best way to create a it is called the most robust approach to create a singleton. Now, what in this particular approach, what happens is that you must have heard of enum. Okay, so enum is used for creating the instance. Now, if you see this, uh, enums are used to create an instance of that. If you see, there is an instance variable over here, and then you have a void the method something whichever the logic what we have written over here. So So in this case, what happens is that it's a very simple implementation. It is thread safe. It is also serialized. So if you see, enums are serialized, right? So it will look into the pitfalls, like there are different ways to crack or break the singleton, right? So enums are used to avoid the reflection uh, break, right? So it will not allow you to create, even if it go via the reflection, because we have a provision to break that particular singleton via reflection, where what you do is that you make your private constructor uh, public, and then you can create that instance. So that is the uh, internal reflection API feature, which is provided by the JVM, okay, Java. So the way to write is that we write the public enum instance, and then we write some logic inside it. Okay. So this is the way to write that. Now, what are the common use cases when we are trying to I mean, when do we use the singleton, right? So basically, when you require some configurations to be shared across the applications, and it has to be it is a I mean, across the application, why you require to create multiple instances, right? So you create it once, you make it available throughout the application. Let's say it is required at the 10 locations, right? It will be created once, it will be available for many. Now let's say you wanted to create multiple database connection poolings, right? So there might be you create the instance, and then you deal with the multiple connections, right? There might be a possibility of 10, 20, but the initialization and managing will be created once, and then it will be available. So those will be taken care in the connection pools. So a number of connections can be reused. Now let's say you want to log something, but in this scenario what happens, you let's say the logger, right? So you want to create, you're logging something, your exceptions, you're writing something, the method started and date, but all things, the initialization of that happens at once, and then it is used at a different location, so that it doesn't always create that instance and then use it, right? So definitely in this scenario, it is the best way to make use of singleton class for this particular scenario. Caching. Now, what happens centralized logging? So you have certain data that has to be loaded up at the start of the application, and throughout that application, it might change or it is not frequently changing. So what happens is that that particular, you can keep it in the cache. Okay, at the start of the application, you create that instance, and then so it is globally available to them. Okay. So when it comes to singleton, as I mentioned, there are different ways to break it, or there are different pitfalls which we can avoid. Okay, in order to break that singleton. Okay, so what happens is that reflection. So one of the important questions when it comes to interviewer, right? So he might ask you, do you know how to break the singleton, or in how many ways you can break the singleton? Okay, so reflection is one of them. Serialization is one of them. Uh, there are two, three ways where cloning on one of them. Okay, so in order to avoid those scenarios, right? So what we have to do is that we have to uh, in the private constructor can be accessed using the reflection, right? So in that case, it will break the singleton. Now to avoid this, what we have to do is that we have to throw an exception in the private constructors. You have to write a logic inside that, even though it is able to make that public, right? So what you have to do is that you have to write a logic inside that where it will throw an exception. Okay, so no matter like it tries to make it public, it will definitely not work, because it will create an instance, it will try to create an instance, it will throw an exception. You cannot change that particular code. Serialization. Now when you're trying to create the process of serialization and deserialization, what happens is that you create and byte your object to a byte stream, and then you convert that particular byte stream to a object, right? So what happens is that in that process, there might be a possibility where you can create a new instance of that, right? So in order to stop that, okay, in order to stop that, what you have to do is that we have to implement a one method called read resolve. Okay, so what will happen, you have to implement that, there is an it will throw an object stream exception. Here you have to return the same instance, not the new instance. So in that case, this will be handled and taken care over here. Okay. So in multi-threading environment, when you're trying to create, you're dealing with multiple threads. Okay. So making use of volatile or synchronization will be the best way when you're dealing with multiple threads, or enum is the best way. Okay. So these are the important points. These are the steps we discussed about, like how to create it, what are the step by steps way to create it, what are different ways to create, what are the different ways to break it, what might be the different questions asked in the singleton, right? So hope you this video is helpful to you. Okay. Thank you for watching.